will cover section 6.2, which is the law of cosines. And the video that I uploaded previously, it only covered the proof of one of the formulas or one of the variations. So here is when we're actually going to get started by solving the example. So I repeat section 6.2. We're going to solve first SAS triangle. So that means side, angle, side. And what we notice is that the angle is in between two sides, so we can say that that will be the included angle, okay? And so we are given the measurements of two sides, 20 and 30, and also of angle A, which is 60 degrees. And we do have a drawing for it. There it is. And so what we need to do is to solve the triangle, and as we discussed yesterday, to solve it, and that means to find all the missing sides and angles. And we also know that we're going to round the lengths to the nearest tenth and the angles to the nearest degree, okay? So since we have side B and side C and angle A, what is the only thing that we can find? What?
Nothing.
Yeah. Can you say ah?
No, like my head hurt.
Oh, okay.
Well,
Well, it is ah.
Yeah.
A, right? I thought that's what you meant. So that's what we were going to do. And so the formula we're going to need will be a squared is equal to b squared plus c squared minus 2bc cosine of a. And you guys notice that I know that formula, right? By memory? Yes? So that means you have to memorize it. Okay, and so I'm going to start by making my substitution. So for b squared, I'm going to have 20 squared. For c squared, I will have 30 squared. And then here I will have negative 2 times 20 times 30. And then we will have the cosine of 60 degrees. Okay, and we're going to solve this by hand. So we know 20 squared is 400, 30 squared is 900. And we know that 2 times 20 is 40, and 40 times 30 is 1200. And we know that the cosine of 60 is 1/2, right? The same as the sine of 30. Okay, so then a squared, if we add 400 plus 900, that gives us 1300. And then negative 1200 times 1/2 is the same as dividing by 2, right? 1200, so that will be minus 600. And so 1300 minus 600 it will be equal to 700. And so we're solving for a, and what I'm going to do is take the square root on both sides. And so here I'm only going to consider the positive square root because we're talking about dimension, right? And it needs to be positive. So the square root of 700, it does not have an exact root. However, we know that we can factor it as 100 times 7, right? Yes. And if we take the square root of 100, that gives us 10, and the 7 is an irrational number. So, I'm sorry, not irrational, but it does not have an exact root. So the square root of 7, that's what is irrational, not 7. Take it back. All right, so then a is equal to 10 times the square root of 7. Okay, now that we have all three angles, now some people prefer to continue using the law of cosines, others prefer to use law of sines. So here it will be your choice. At the beginning, there's no way you can use law of sines, but at this point, since we already have an angle, and we have the opposite side to it. That's why we're able at this point to use law of sines, okay? So in this case, it will be the side, 10 square root of 7, divided by the sine of 60. And that will equal, and then let's take another ratio. So I will take 30 here. And then the angle right across from it, so that will be angle C. So that will be sine of C. So in this case, what we are going to solve for is for the angle C. So here we could do, to solve for the sine of C, we could I didn't show you guys this the other day, but you could do this also if you have trouble solving for it. You could try to cross multiply. So if we do that, we will have 10 square root of 7 times the sine of C. And then on the right side, I will have 30 times the sine of 60. Yep. And then remember, we're still trying to solve for the sine of C. So what we need to do is divide by the 10 square root of 7. Correct? So sine of C is equal to 30 times the sine of 60 divided by 10 square root of 7. And don't worry about rationalizing yet, because we could do two things here. You could go ahead and get what is the sine of C, or you could, I will suggest, since we know we are going to have a solution, the other day we were trying that first just to see if we got a value greater than 1. What I would do here, what I would suggest you do is that you take, you solve for C, and so that will be the sine inverse of all this stuff here. Okay, so if you guys can please type that in your calculator. And oh, you guys don't have calculators because you're waiting on me to write the answer. Come on, Robert.
No. Oh my God. He gave you the one you always like. Yeah, you should do it. Yeah. You ever notice that when you get one delivering treasures?
Okay, so oh yeah, I don't even have that answer, so I need you guys to find it.
But he said he solved them.
Huh? I didn't finish. I found B, not C. Oh, but if I know B, I should know C. Let's see if you guys get the same thing.
What'd you get?
What do you get?
It doesn't have that at 35 degrees. At 79 degrees.
79 degrees.
That's when he gave you that.
Make sure that it's in degrees because remember, we're talking about the sine of 60. So make sure that your calculator settings is in degrees. So you should get 79 degrees. And the reason I didn't have that one is because I started solving for B. So I used the law of sines to solve for B. And then what I did was that I found angle B, this one, was equal to 41 because we rounded to the nearest whole, the nearest integer. And so at that point, if you know the second angle, it's really easy to find the third angle, right? How would you do that?
180.
So if we say 180 minus the angle given, that was 60. That gives us 120. And then minus 79, that will give us 41. All right? So let's go to the next slide, please. That's a checkpoint. I'm going to leave those for you to try at home. You can pause the video if you want to. I'm sure you guys will have fun doing that. Next is the solving an SAS triangle, which means side, side, side. And we're going to use the law of cosines to find the angle opposite to the longest side. And we're also going to use the law of sines after that to find either of the two remaining acute angles. All right. Now, the third angle will be found by subtracting the two angles found from 180. So, again, we have a picture for it, and we're going to solve for the longest side. the angle opposite to the longest side. So that will be A, correct? Yes? Okay. So then we're obviously going to use this formula, A squared, the angle opposite to the angle opposite to the longest side.
Oh, that's correct. Because A is equal to 9, and 9 is...
Oh, B is bigger. Oh, yes. I'm sorry. I don't know what I was thinking. That one, right? It's obtuse.
Yeah.
Okay. I'm sorry. It's just that I'm already on spring break mode.
That's okay.
Okay. So, all right. So we're talking about angle B. So what I'm going to do is use the variation of the formula that goes this way. B squared is equal to A squared plus C squared minus A, no. Minus 2AC cosine of B. Right? Okay. So now we are trying to solve for angle B. So what we're going to do is solve for B before we start plugging in things, okay? And so what I will do is, you guys notice how the expression that contains cosine B is negative? Yeah? So what I would do is take that whole thing to the other side, correct? So if I do that, that will take care of the negative sign, and so we will have positive 2 AC cosine of B. Okay, now my A squared is still on the right side, my C squared is still on the right side. But now the B squared, that used to be on the left, I want it on the right. So it will be negative B squared. Okay, now I think all of you can tell me what are the 2AC doing to the cosine of B? Multiplying. So if we take them across, what are those terms going to do? Divide. So we have A squared plus C squared minus B squared divided by 2AC. Now, how do we undo cosine? What is the inverse one? Cosine inverse, right? So B is equal to cosine inverse of that whole expression. A squared plus C squared minus B squared divided by 2AC. And so that is the formula that we're going to use. Okay? So let's go ahead and start plugging in. Oh my gosh, that looks ugly. So for A, we have 6, so it will be, I'm sorry. Should we do that? I feel like I'm getting a little ahead. Let's try it this way. So cosine A is A squared plus C squared minus B squared over 2AC. So the cosine B, if you guys just want to jump straight into the other one, feel free to do so. So if we substitute the A with a 6, side C with a 4, and side B with a 9, 2 times 6 times 4, correct? Yes? All right, so we will get 12 plus, not 12, we're squaring, so 36 plus 16 plus 81.
You want to subtract it, because it's minus B squared.
Oh, yes, it is minus. Thank you. So minus, so this will be minus. Maybe I should just look at my notes. Okay, and 2 times 6 is 12, times 4 is 48. Okay, and so we're going to get negative 29 divided by 48. And so if you do that, B will equal the cosine inverse of negative 29 divided by 48. So can you guys do that on your calculators, please? And make sure you make that 29 negative. here we're going to get an approximation. So I want you guys to round to the nearest integer. And like I said, you could do your substitution here and just get the cosine inverse from there. Okay, so Robert, what do you get?
127. Yes.
Yes?
Yeah.
127.
127. Okay, pretty good. Now, I want to point something out. If we had one of the older calculators, we couldn't do such an operation. You cannot take the cosine inverse of a negative one, because the cosine is defined like this. So you only take positive angles. I mean, you restrict the cosine function from 0 to pi. But because you have those new calculators, that's why you got that it was 127. So consider yourself lucky. All right. Now, if we know two of the angles, can we find the third angle? Oh, we don't know the second angle yet, but we're going to find it, right? Okay, so at this point, we're going to use the law of sines. And just so that we do the same one, let's try to do this. So we're going to do A divided by sine of A equal B divided by sine of B. And so I'm going to use B over sine of B because I already know the side, and that one is equal to 9. And I know what angle B is equal to, so it will be sine of 127 degrees. So for my right side, I will have 6 for side A, and then what we're looking for is angle A. Yes. Let's do. Okay, so what I'm going to do is cross multiply them. You guys can keep working and then just check your answers with mine. The 9 is multiplying, so it's going to divide on this side. So for A, that will be the sine inverse of this one. Jessica, are you trying on the calculator? Come on.
Isn't it over 9?
Yeah, it's 32. 32.
Like it's not over 6, it's over 9 or...
That should be a 9, that's true. Okay, so what do you get, Jessica? 32. All right, yeah? Okay, so now we know two of the angles. We know one of them is 127, and the other one is 32. So if I add those two, I will get, what would I get? 159. Okay, so now to find the third angle, you could find it by subtracting 180 and 159, and so that will give you what? 21. All right, and so that will be our third angle, which happens to be angle C, 21 degrees. All right, so we have finished that one. So let's move on. So again, checkpoint 2, that is for you guys to try over spring break.
Are you going to give us a practice test?
Oh, no, I'm not going to give you guys a practice test because I've learned that you guys, that's the only thing you guys study. which is not right, because I'm never gonna make an exam exactly the same way. And so what I'm gonna do is make a study guide sometime when I get a chance, and then I will upload it to Edmodo. Okay? That's better than nothing, I think. And what I'm gonna do with the study guide, it will be similar to the practice exam, but I'm gonna put more options there, more problems for you to work on. Because, for example, if on the previous exam, I think I gave you a cosine graph, correct? But I asked on the practice exam it was cosine, but on the real exam it was sine. So what I want you to do is to explore different options and not just one problem. Okay? So it will be a study guide. I promise to make a good one. I know Alpha will pressure me to make one, so I will make it, I promise. I don't know when, but I will. It will be up sometime by Monday. Okay. All right, so we have a word problem, and this is an application of the law of cosines. So we have two airplanes leaving an airport at the same time, but they go on different runways, which they should, right? And one of them flies on a bearing of north 66 degrees west at 35 miles per hour, while the other plane flies on a bearing of south 26 west at 300 miles per hour. So let's talk about both of those. So plane one is going at 325 miles per hour, and plane two is going at 300 miles per hour. Okay, so if that is per hour, how many hours are there? What is the denominator? How many hours?
2 hours.
Well, here. That means per hour, right? It's just 1 hour. Okay.
Yeah.
That's where I wanted to get with that. So the speed tells you for every single hour. So now they're flying for 2 hours, right? That's the question. How far apart will the airplanes be after 2 hours? So I think we need to multiply by 2. So that we know what's the distance traveled, right, in 2 hours. So 325 multiplied by 2 will give us 650. Then 300 multiplied by 2 will give us 600. Okay, now let's go ahead and draw a little diagram. Okay, and so we're going to have the first plane. Here's the airport at the origin, and so the first plane is going north and is going on a bearing of north 66 west. So we're going to go from the y-axis to the left. And so we're going to calculate 66 degrees for the bearing. So I'm estimating somewhere here. So this, well, that looks more like 45. Let me change it. Okay. So it looks a little bit more like it. So that's 66 degrees. All right, that's plane one. Now the second one is going south 26 west. So again, we're going to go from the south line, but now to the left again because we're going to the west. And that will be 26 degrees. So that will be less than 30, somewhere over here. Okay. Now I'm going to make the green line slightly shorter because the speed is slower, so the distance traveled will be less. Okay. Now, the question is asking how far apart, and let me write down the degrees here, so that's 26. And the question is, how far apart will both planes be after 2 hours? So that is what we're trying to find, the distance here. Okay? Now, what do we know about this triangle? The triangle that you guys could see forming inside. We don't really have any measurement for it, right? But we could find one. And it's actually pretty easy because I know that how to find this angle here. And I want one of our geometry students to tell us. This. The one in red.
180 minus 66 plus 26.
Okay, so 180 minus 66 minus 26, right? Because, and I want another one of our geometry students to tell me what is the name of an angle like this one here?
Straight.
Straight angle, okay. So that's why it is equal to 180, right? And that's what Stephanie told us, 180 minus 66 minus 26. All right, so you see geometry is actually useful. Okay, so if we subtract that, we're going to get 88. 88 degrees. Okay. All right. So now I'm going to just go ahead and draw the triangle here. And so far we know this one is 88. Okay. And then remember how at the beginning we multiplied the speed or times 2, right? So now to know the distance, and so the distance is going to be the length of the triangle. So this triangle is the one, this side here is the one of the airplane, the second airplane, so the length of that side will be 600. And now this side here was, that corresponds to the first airplane, so that is 650. And of course those are miles. Okay, so let's say that you want to call, well, let's refer to this as A. This will be B. And so this point here, we'll call it C. Oh, maybe I should have started with A with the origin, but it doesn't really matter. So if this is C, and this is B, and this is A, then this side, the 600, will correspond to which lowercase letter? Lowercase a. And so the 650 will correspond to which lowercase letter? B. Okay. And so we only have one of the angles, angle C. So the only variation that we could use of the law of cosines is the one that contains sine of, cosine. Cosine of angle C. Exactly. Okay. I need more room. Okay, and so that will be the c squared is equal to a squared plus b squared minus 2ac cosine of c. That is wrong. This should be a b. There you go. So it is a squared plus b squared minus 2ab cosine c. And so let's start substituting what we have. So for A, we have 600. For B, we have 650. And then 2 times 600 times 650. And then times the cosine of 88 degrees. Okay, and since we're trying to get done with this lesson, I'm going to go ahead and write the answer for you. So c squared is equal to 755,278. And so now we want to solve for c, now for c squared. So of course we need to take the square root. And if we do that, we get approximately 869. And if we go, the problem doesn't specify how much they want us to round. But since they were giving us miles per hour, I will just round to the nearest integer. Okay, so let's go to the next slide. So we're going to skip the checkpoint, that's for you. And then we get to the last item of the section, which is Heron's formula. And this formula is to calculate the area of a triangle. So if you guys recalled, from last section, 6.1, we ended with a formula to calculate the area, correct? Okay, so we ended with a formula to calculate the area, right, of a triangle. If you don't remember, you can look at your notes. So now this is another one that you could use. And there's a very interesting proof on that one. Maybe one of you will get it for your honors credit. And so it's like a 2-page long. Maybe we'll give that to Ivan. And then, or Jesus. Okay, so then what we do here is pretty simple. And what you have to consider is that A, B, and C are representing the sides of the triangle. Okay, so it doesn't matter what triangle it is. It could be, it doesn't have to be straight. It doesn't, in fact, it's for any triangle. And so what you do, not C, but S, is 1/2 of the perimeter. So that's why we have A plus B plus C, that will be the perimeter, and then half of the perimeter, so that's why you multiply it by 1/2, okay? And remember, multiplying by 1/2 is the same as dividing by 2. So what we're going to have to find, of course, we need all 3 sides, and then we're going to find S, because S is needed in the formula, and we actually need it 4 times. You guys notice? Yes? Okay, so let's go ahead and find S. And so S is going to be 1/2 of the perimeter, and so the perimeter will be 12 plus 16 plus 24. And so that will be 1/2 of, what would this be? 52, right?
Yeah.
52, and then so half of 52 is 26. Okay. So that was just something that we needed for our formula. Now let's go ahead and use the formula. So the area will be the square root of S times, and this one you do have to memorize. And it's pretty simple because you just need 4 things multiplying, 4 factors. The first one will be S, the second one will be S minus A, and then S minus B, and then S minus C. So it's pretty easy to remember. So let's go ahead and do our substitution. And so for S, we have 26. S minus A will be 26 minus 12. S minus B will be 26 minus 16. And S minus C will be 26 minus 24. And so here we have 26 times 14 times 10 times 2. And so you guys are going to have to do that one because I don't have the answer. So type it all into your calculator. I mean, you could type this whole thing. Just make sure you're careful with the use of parentheses. And then if you take the square root, what do you get? Where are you guys going?
4 times the square root.
85 yards.
Where are you guys going? Sit down. Thank you.
85 yards.
Does this class end at 3:10?
Yes.
Okay, so my bad. You guys should go. Okay. All right, so this is the end of the lesson. Go ahead. I owe you guys time. I'm so sorry. You could just leave your calculators there. I'll pick them up.
Don't worry, I'll help you. I'll have it straight anyway.